This is Swapnil Bhartiya with Rob Hirschfeld. This is our limited series on scaling infrastructure as code. And in this episode, we're going to talk about repeatability. How would you define repeatability?
So repeatability, on the surface seems to be very simple. Fundamentally, what we expect for repeatability is that when you ask for something to happen, it happens the same way that you would expect, right? So this is what we're looking at. If I do something, does it happen over and over again? In a developer experience, it's very straightforward. If I'm using a library or writing code and I click a button, I expect that button to click every single time. For infrastructure, we have a different challenge in repeatability because infrastructure is not just running the same path over and over again. As we build infrastructure, we're actually bringing in completely new components over and over and over again, or recycling components over and over again, or using different pieces. And so when we look at this infrastructure as code piece, what we're really trying to get is having a consistent experience that is working even when the infrastructure that we're using it on is different under the covers. And so this is where we really get into the concept of repeatability for infrastructure as code. It comes back to an expected behavior of the system over and over again. And what would happen here is that when we're talking about automation, so the repeatability for infrastructure as code is that the automation achieves the same result, even if the underlying systems and infrastructure and components are different. And that's a place where I think repeatability from an infrastructure as code perspective needs to be understood differently. It's about achieving the same results over and over again with different underlying components.
When people talk about or kind of just add, slap, glue as code to things, are they talking about dev experience? What does it mean, and does that have any repeatability factor into it?
Yeah, the as code suffix is very similar nowadays to what people did with as a service, where they just stuffed it on the end of everything they wanted. For us, when we add in as code, it really is a statement about the developer process and how you can decompose writing automation into reusable blocks, how when you build automation, you can test it. I think people really underestimate the components of a dev-like experience where it's modular and they're modular pieces, there's test processes and test components and validation steps, that contributes dramatically to repeatability in ways that people aren't thinking about. Let me be even more specific. Nobody would expect a developer to write code and not test it, or have it work in every situation and not build a test infrastructure to make sure that the code kept working. But we often do with automation. So we're like, hey, it ran once, that's great. If we want to write, infrastructure as code, we actually have to have ways that we can test and verify that it works in many scenarios on different environments, and has a durability to it as things change under the covers that they can count on. And so there's a big added piece in here when we add as code into the repeatability statement.
Does that also mean that automation is not always repeatable?
Sadly, it's not. We talk to customers who have infrastructures with as high as a 20% failure rate on some of the processes that they go through. Especially if you're doing bare metal and you make small mistakes in bare metal, they accumulate over time. But yeah, it's automation, because it's not rigorously tested, or because it doesn't handle edge cases well, often has high failure rates. And one of the dangers in automation that we've seen built is a lot of that is hidden by retries. And with automation, you can build in a retry. Oh, it didn't work this time. I'll just keep reasserting that I want this to happen. And sometimes that hides problems very effectively. In some cases, in infrastructure, it makes problems a lot worse. And you can keep trying something until the system's really broken in a very unrecoverable way. We see that behavior a lot. One of the things that we encourage with RackN is people to not keep trying if things fail. So if something breaks, this is how we fix failure rate is if something breaks, we stop, we try and give very good errors, and then we fix the root cause of that problem or provide additional checks or balances to make sure things work. It's incredibly hard to make automation that's resilient from that perspective. And eliminating retries, ironically, is the number one way not on our list.
Yeah, can you go a bit deeper into also what kind of factors make it hard for automation to be repeatable, and how does infrastructure as code help there?
Yeah, this is something that I think is underappreciated in for operators and DevOps people and people who do automation for their living, is that when you're dealing with infrastructure, there's a lot of things that are outside of your control. And there's a pretty deep dependency graph of things that have to be working just right for that to happen. And so it's very hard to make automation repeatable when the operating systems that you're building on keep changing and being patched and updated, when the infrastructure that you're dealing with has variation in it that's caused by new firmware being rolled out or new devices changing or device enumeration changing or an API for a cloud being different, or a tool as part of your tool chain going through some behavior change or version update or not being available anymore. And so when we're building infrastructure, then we actually have to accommodate all of these variances on an ongoing basis. And so something that you thought was rock solid and working might stop working one day because of something that you had no control of. I'll give you a very concrete example. When CentOS switched over to CentOS Streams and Red Hat shut down the mirrors for CentOS 8. And on April 1st, it was March 1st, all of a sudden you couldn't patch, you could do an yum install anymore if you weren't using the right mirrors. So something that had been working great for years all of a sudden stopped working across the board. And that's a day in the life of an operator. So you have to be ready to accommodate that. Sometimes you can predict them because they give you a heads up, and sometimes things happen on the internet and you have to be able to respond.
Since you talk about kind of predictability, so let's talk about the importance of consistency also. As we talked about earlier also in other episodes, that systems are different, so they are also spread across. So how can you achieve consistency across such systems?
So one of the ways that we look at consistency, it's sort of about the end result and the experience. And what we do to make things consistent is not sort of force them all to fit in the same mold. We deal with this with customers who want to buy one vendor's hardware. They want consistency. They want to enforce consistency in their environment by trying to make everything the same. And this is the irony with consistency. That the way we look at consistency is about collecting data across the board and normalizing information that we collect, and providing a path through. It doesn't mean everything takes the same path. Dell, HP, Lenovo, Amazon, Google, Microsoft, they're different. They have different APIs. You have to treat them differently. That's fine. So you're not going to get consistency out of that experience. And the idea that you're just going to stick with one vendor for everything works, but for some people, but for most people, it doesn't work. Or even if you try to do that, the vendor might change on you and you're going to have to adapt to it. The strategy that we take is to acknowledge that things are different and going to be different. And then we make it possible to shift paths to get through to the same result. So a lot of the places where you have inconsistency at one step, they normalize again in the next step. And so the way we approach that system is to take the data that we're collecting across different systems and then have standard variables or normalized variables for that, or have different paths that then reconverge back into the same steps. And so it really is a flow conversation for consistency rather than a starting point definition for consistency.
Let's talk about APIs. Most people talk about APIs as abstractions, but is that true? And if I can ask you, how would you define abstractions here?
Boy, this is a really important point, and it actually goes back even to some of my industry work in helping like OpenStack and then in the early Kubernetes days, those platforms define what they meant from an API, a core definition perspective. And what we found was really simple. APIs are important, and having consistent APIs are important. And they are definitely an abstraction point. But behind that abstraction point, there is a considerable amount of behavior that is in that API. And so what can happen very easily is that you can use an API consistently, and then what gets delivered to you or the way the API responds to your requests changes over time. And so that abstraction boundary has to be, you have to understand that it's actually a behavior that you're getting, not just the data that the API returns. And I think that this is an important component for this, is that we have to be able to look at that not just from here's the data that I'm getting, but here's the results, here's the actions that I'm expecting to get out of that API. And so we look at this not just as an abstraction boundary, but a behavioral prediction boundary. For RackN, and what we do with the system is that we go beyond just version control, and we have something called a feature flag into the API that define the behaviors of the system. And so as the behaviors are added into our product or change in our product, the feature flags help identify whether or not the behaviors that people expect are in place, not just when I ask for something. And so that's a big part of how we're working for infrastructure as code, right? We're actually building systems and doing workflows and things like that. And so an abstraction might be, hey, run this workflow, but the workflow is actually implementing a whole bunch of behaviors. And so you have to understand both pieces to this. So it's much further than the API.
Let's quickly talk about portability as well. Does modular or usable code kind of help create portability? If yes, are people doing it? If not, is it because it's too hard?
This is the place where when it works, it's amazing. So we see a lot, and let me back up, because this is RackN's core mission, right? We want our customers, our community, to be using and reusing automation blocks, right, across the board so that they have very consistent experiences, right? One of the hardest things to do in IT is install VMware. And so when we built our VMware workflows to do that install, these are really pipelines. Those pipelines are consistent and reused customer to customer to customer. And when we improve them, all of our customers get the benefit of doing that. That's reuse in a nutshell. And to do that, what we had to do was recognize that all of our customers want to use the same automation, and all of our customers have different needs. And there's a paradox here of I need to have a consistent pipeline that runs through it, and I need to have things that fit my needs specifically. And this is where the pipeline concept for us really took shape. When we build a pipeline, we actually include known specialization and configuration points into that process. And that's where we come back and say, you know what, we have to allow our customers to extend a pipeline in a predictable, configurable way to do this. And this is what makes reuse really important. If you were a developer and you were using a module, and that module didn't have a way to extend or add or inject pieces without rewriting the module, then you would be really frustrated. You'd be like, wait, I can't use this code because I have to keep changing the module. And when the authors patch the module, my patches are lost. That's what code is like. Automation hasn't been like that before. And so when we went out to build a code-like experience for automation, we had to come back and say, how do we make a module that everybody can reuse? And then when they need to set their own custom stuff into it, they can still keep taking patches and updates of that module. That for us was this pipeline concept with known injection points where you can add additional tasks and pull additional data into it. And it's been transformative in how our customers use the product, because they're actually able to sit down, use a pipeline, get it working out of the box, and then start flipping switches to make it custom to their environment. Those customizations we don't worry about them breaking the module because of the way the system has been designed, but it's an important concept to think through.
Let's talk about day two operation. How does this work in practice, in real?
Yeah, day two is probably the most critical piece about repeatability, right? When we talk about repeatability, it's fundamentally a day two concept that I can keep running my automation over and over and over again. And what we see in this is day two needs to be able to say, I'm confident that when I make a request, it's going to be executed reliably. But the other dimension in this is the expectation that your automation and your systems will change over time. So you have to be able to build your systems in a way that when new requests come in, they're addressed reliably. And when the automation, the behaviors of your system under the covers change, you can roll those in a reliable, repeatable way. And that's a dimension I think most people don't think about in repeatability. It's not just can my system respond every time I ask it to do something, but can it take a patch and an upgrade and a change in a reliable, repeatable way? Can I constantly be updating and changing my system as we go over time? And so day two takes on a totally different meaning when you start looking at rolling upgrades and patches and synchronizing sites and staying in sync with a broader community who's patched and fixed systems. And so this day two idea of how do I orchestrate a rollout to the configuration of my site or the automation my site's using or the artifacts that my site are using are super important. And we have to have a process for that just as much as we have to have a process for, patch this cluster or change out this server. They're combined concepts in this.